So quick reminder, homework 2 is out. I know most of you are thinking about homework 1 still, but those of you who have homework 1 done, homework 2 is out. And especially on Friday, we're going to start, like Friday covers a big chunk of homework 2. So just a heads up on that. Today's lecture is, I think, one of the more fun ones. I mean, you all will be the judge of that, but let's get into it. So we're going to talk about JavaScript and add some functionality, some interactivity to our front ends. Oh my goodness, I'm on the wrong thing. Add some interactivity to our front ends where the user can actually interact with our content. I'm not really going to cover JavaScript in any great depth. I'm just going to show a couple very basic examples. Then I'm going to point you to W3 Schools, just like I did on Monday with HTML and CSS. It's not a big focus of this course to dive into, okay, here's how to write a function in JavaScript, here's what a callback is. Like, I'm just not going down that road. If you're curious, you can ask me about it after lecture, and I'll be happy to go through examples. But I'm not going to take up too much lecture time itself on that, because we got to get to the HTTP stuff and the web server stuff and building web apps. That's what we need to get to. And specifically the back end and the networking of that app. So let's do some JavaScript. One lecture of this. too many existential, existential, I can barely say that, thoughts, especially for so early in the morning. For anyone watch this on YouTube, it's we're having conversations before lecture. It got a little, whenever we talk about AI, it gets a little wild. So JavaScript, this is just my slide that I already said. I'm not going to go through like 115, 116 material. At this point in your careers, you're expected to be able to pick up a new language fairly quickly and without any instruction. Even for 200 level classes and 220 learning C, there's not that much instruction on C itself, just the new concepts that C introduces. Pointers and references, for example, get covered. But it's not like, here's a loop, here's how you write a function. That stuff goes by real quick, and at the 300 level, not at all. You're expected to pick it up pretty quickly. Go through W3 Schools. It's got a great tutorial. It gets you where you need to go, especially for what you need in this course, which is very little. Some of you might be able to get through the whole course without writing any JavaScript, especially if you're not doing the bonus objective for homework 2. And somebody else on your team is doing the front end for your team project. You get away from the whole course without writing any JavaScript, potentially. Okay, so we've seen the basics of the site, HTML and CSS. HTML builds the structure, and CSS adds style to that. Messes with changes the coloring, changes the fonts, things like that. How is this data organized from the structure in the HTML? HTML is the structure and also the content. CSS is the styling on top of that. This gets us, a little bit, gets us to a decent point in web development. But we can build what I like to call poster sites. It's like printing out a poster and then pinning it up somewhere, pinning it on like a bulletin board in the hallways of campus. That's effectively what you're doing. You're pinning up a poster on the internet. This is great if you have like a business and you just need to advertise your phone number and say, call us for details, or your email address, email us and we'll talk. Contact our sales department and we'll discuss things further. And you just want to advertise something. Poster site's great. It works well for that. You got a small family restaurant or something. You just want to post the menu online and your location and say, come check us out. It's perfect for that. But that's not really what we're interested in this course. We're interested in building web apps, not web pages. Our web apps will have web pages, but we want that user interactivity. So let's take the first step towards user interactivity and add JavaScript to our HTML and CSS. So once we add JavaScript, we're going to be able to get more functionality and more features in our websites. And then we'll eventually have our JavaScript communicating with our back end, with our servers. So we're going to use JavaScript. I'll say JavaScript throughout the semester. I'll always refer to it as JavaScript. Technically, it's ECMA script. We're on ECMA script 6. I haven't been paying attention if the next one came out. But it's technically a ECMA script is the standard. That's what defines the language that runs in browsers. JavaScript is one implementation of that standard, and there are different implementations of ECMA script. So just a heads up, if somebody throws some trivia question at you, like technically JavaScript, ECMA script, and they start spewing things like that at you, just a heads up, that's what they're talking about. ECMA script is the standard. ECMA script is not a language. JavaScript is a language that implements ECMA script. It's somewhat similar to how like Java and Scala and several other languages all compile down to Java bytecode and are ran on the JVM. It's somewhat similar to that, where the JVM runs Java bytecode. Your browser runs ECMA script, anything that complies to this standard, and then JavaScript happens to be one of the languages that complies to that standard. So just a little bit of trivia and background. I'll just say JavaScript throughout the semester, and I'll blur the lines with the distinctions between all that. I believe TypeScript is another implementation, if I'm not mistaken. I haven't used TypeScript to be honest. I believe TypeScript is another implementation of a language that satisfies ECMA script. Or it compile. Okay, thank you, Jesse Lee Hartloff, my doppelganger. So it compiles down to JavaScript. That's helpful. So I was wrong on that, but and there are a few languages that compile down to JavaScript. I thought TypeScript was. Google says ECMA script is a language. I'll check on that after lecture. Yeah, I'm fuzzier on this than I expected to be. I'll check after lecture. We can do some searching and get down to the answers on that one. I thought it was just a standard, not a language. Like the definition of an API that a language that satisfies that has to comply with. I'm not aware of an implementation named ECMA script, but I could be wrong. It's possible. It's happened before. So let's talk about some JavaScript. And first, HTML and CSS are not programming languages. Technically, a student called me out on this one before, so I have to add this caveat. HTML is not a language, is not a programming language. It's a markup language. CSS is, I got to be careful here. I believe CSS is not technically a programming language, but the combination of HTML and CSS, those combined, since CSS can use the HTML DOM as a data structure and as variables, I believe that's when they do become technically a programming language. Technically, they're Turing complete. So if you like the technicalities, HTML and CSS combined do form a Turing complete programming language. It's not something you'd ever want to use. You don't want to use that as a programming language. Besides just being bad practice, your code is going to be completely horrible to read. Nobody's going to be able to read that. But technically, and there are people who built really feature-rich websites just as hobbies, not as, serious stuff, I don't think anyway, out of just HTML and CSS, a lot of interactivity and stuff like that. For the rest of us, JavaScript is the programming language we want to use in the browser. We're going to use JavaScript to give our code more interactivity and more life, really. This is going to let us write any code, anything that you've been learning for the past few years, how to write code. That's what we're going to use JavaScript for, not HTML or CSS. There was no way to write a loop that we saw in either of these languages. JavaScript has us covered there. Oops, I got a lowercase l. JavaScript has us covered there. When you have JavaScript on a page, like you as a user especially need to think about this, is when you visit a site, you download the JavaScript code for that site and then run it on your machine. You're downloading some code that some developer wrote and you're running it on your machine. What are the security implications of this is the question I want to ask. So if you're running somebody else's code on your machine, what do you need to be concerned about whenever you're doing that? Okay, so it sounds like there's no implementation of ECMA script just from that blurb that somebody unknown put. But I'll dig deeper on that. That JavaScript existed, and then the ECMA International came along and said, let's write up some documentation for JavaScript and call it ECMA script. And then the other languages also implement that standard, if I'm reading that right. So they technically call it a programming language, but it's not an implement. It itself, ECMA script itself, is not an implementation. Like, you wouldn't type code and say, I'm typing code, I'm typing ECMA script code, is what I meant. So maybe the terminology, I'm getting mixed up here. But like, you don't type ECMA script code. You type in a language that's ECMA script compliant, like JavaScript. So my wording might have been off there. Yeah, exactly. Developers can mine Dogecoin on your machine. This is injection attacks, cross-site scripting, worms, viruses, malware, backdoor, all of this stuff. All of this stuff can happen. If you're downloading somebody's code and running it on your machine, I mean, what can you do with code? You can read files, you can write files, you can modify things, you can go into system settings and start changing them. Anything that's stored in a file, I'm hung up on file.io here. You can make HTTP requests to other sites and start gathering cookie information that's in those requests. So a lot of stuff you can start messing with when you're running somebody else's code, which are always concerns when you're downloading desktop apps or apps on your phone, mobile apps. You're downloading somebody's code and then running it on your machine. You better trust the people who wrote that code. You better trust those developers. Because if you get some third party, some little known outfit, download their software and install it on your machine, well, that could be malware. You might have some ransomware on your machine now. It'll lock down everything and say, pay us money or else we're just going to delete things and keep your computer locked. A lot of bad things can happen here. So we need to be conscious of the security implications here. JavaScript, specifically browsers running JavaScript, are aware of this. And there are a few restrictions that JavaScript cannot do for these security reasons. So when you're developing sites and you're like, man, why can't I read and write files in JavaScript? Well, you can't, because that's a huge security risk. So the browser is not going to let any JavaScript code. There's no functionality in JavaScript. Unless you're using Node in Node, there is this functionality. JavaScript in the browser cannot read and write files. I see this a lot. Beginning web developers want to host a settings file on their server, access that settings file through HTML, like download that file, and then use their JavaScript to read those settings and then do whatever it needs to do. Or maybe you have a saved state. You have a game and you want saved files. Store them on the server, send the saved file. You can't send the file because you can't read that file in JavaScript. Even if it's your own file, you just cannot read any files in JavaScript in the browser. Can't do it. Can't access other tabs or windows. That one should be obvious why that's not allowed. You can't just start working your way around the entire browser and stealing everything. You can't. I didn't push my slides again. I made very few changes, so that should be fine. But you can't. Added easily here. You can't easily access cookies and local storage from other sites. There are ways to steal cookies if the other sites are not protected against that. There are ways to protect against it too. There are ways to steal cookies, but you can't just access them directly. You can't write JavaScript that says, read your google.com authentication cookie. You can't just write that code and read it. You can try to make a request, an AJAX request to Google, get the response, parse the cookies, and check the cookies there and then steal them and then send them to your server. You can do that, and sites like Google or any site that's security conscious at all should be locking down those cookies and not sending them to third-party sites. It shouldn't be sending them to those sites. They should be only sending those cookies to the same origin as the domain that set that cookie. Yeah, hands off the cookie jar. Where does local storage come into play here? It's another thing you can use that gives you kind of functionality as cookies in a way, as long as the server doesn't need that information, or if the server does, you read it from local storage and then send it. So in your JavaScript, you can write code that will store information on the user's machine instead of setting it as a cookie and then sending on every single request. If you only need the user to see that information, you could save it. So like CSE312.com, I use local storage to remember what's collapsed and what's expanded. So if you collapse the syllabus, that flag, there's a flag that says the syllabus is collapsed that I saved to your local storage. So my server never actually knows that you collapsed that that section, that syllabus, that section of the site. So the way you were taught in like 199 before, well, does he cover local storage? Anyway, instead of setting a cookie, because you can do that with a cookie, set a cookie that says syllabus collapsed, and then have that go on every single request. Instead, I just do it as local storage, and then I have JavaScript that reads your local storage and says, oh, this flag is set. Make sure that's collapsed every time you load the page. So you can't access local storage from other sites. So on 312.com, CSE312.com, I can't have JavaScript on that site that says, go into your Piazza and read the local storage that Piazza saved on your machine, and then send that to my server because I want to know that information. I can't do that. It's not something that I can do. So the browser is going to stop all of this. None of this can happen. There are vulnerabilities. It's a cat and mouse game. It's a constant battle between good and bad, I guess. But there are sometimes vulnerabilities found in certain browsers. They're exposed, they're patched, and you constantly get, when you get security updates, download the latest version for security reasons. It's usually things like this. Some attacker found some really sophisticated way to get to another tab, break out of the current tab. We patch it, the browser developers patch that, and then release the update. All right, so with the security stuff in mind, let's look at some JavaScript. A very simple JavaScript here. I'm not looking for features. I'm not looking for anything fancy. I just want to show you a JavaScript script. So in this script, I'm going to get a certain element by ID. So on Monday, we had an element that we gave an ID to that had to be unique. Now in JavaScript, we can access that element with this get element by ID. Say, give me this element with this ID, which has to be unique, and then start messing with it. Here, I'm going to set the inner HTML. So it's going to set all of the content in between the open and closing tag with whatever I want it to be. And I'm just going to write content added from JavaScript. Very, very simple. Simple as in I'm not doing anything fancy here. It's new syntax, it's new stuff, of course. But from a user perspective, that's what I mean. User perspective would not be impressed by this at all when I say simple. So to get this script to work, this 2-line script, we're going to have to import it from our HTML. We're going to import our JavaScript. So I take this code, I save it in a file, which I didn't put here, but script.js. I'm going to save that in a file called script.js. And then I'm going to add a script tag, a script element to my HTML. At the bottom of the body is typically the best place to put it. Sometimes you'll see these in the head as well. For a script like this, it's got to be at the bottom of the body. So when the browser renders this, it's going to render all this HTML. And I want to make sure my div here is rendered, is parsed before my script runs, because I have to access that div by ID. If that div doesn't exist when my script runs, then my script doesn't really do anything. So I have to have this script after that div. Technically you can get away with it because there's a network delay in retrieving this file, which is gonna get us what we want anyway. But you don't want to rely on that. So I put my script after this. As soon as the script tag is parsed by the browser, it's going to make a request for script.js. And once that script is downloaded from the server, once that HTTP request response comes in with that JavaScript is executed right then. Once you get that JavaScript, then it's going to execute. So when this page loads, this JavaScript is going to run minus network delays. This is going to run right away, and that content is going to show up. From the user perspective, you'll never know that this was added through a separate request through JavaScript script, and then that was executed and modified the HTML on this page. You'll never notice that from a user perspective. This is just going to show up exactly as this. It's going to load almost instantly, but depending on the network delay, like if you have a half a second network delay, this is going to show up, and then this is going to show up after. And you'll notice that you see that in modern websites, modern web pages all the time. The page loads fast. Fast page loads is a huge thing from a user experience perspective. You want the page to load fast. So the page loads fast as possible, as fast as the web developers can get that content to you. And then after the page loads, there's a lot of JavaScript that runs. There's the more heavy tasks, anything that needs database access from the server, the more computationally heavy, more expensive tasks. That content is going to load after. So, for example, your page loads, and then maybe you're on a social media site with posts from all kinds of different people. There's got to be some AI algorithm that runs to decide which post to send you. A lot of really expensive operations. That content is going to load a decent amount, at least a noticeable amount, after the page itself actually loads. But the page is going to load fast. You're going to see something as a user right away. By the time you look around the page and see what you're assuming it's a page you haven't visited 1,000 times. By the time you look around and see, okay, this is the page that I'm at, bam, then the content is there. From a user perspective, we don't want to wait. So you see this a lot. Content that's added through JavaScript, through AJAX calls, through a lot of processing. That's what's happening. The JavaScript is running after the page loads. For this simple JavaScript, you'll only notice the network delay. So only if you have some, if the network takes a while, that's the only way you would notice this loading after. jQuery would make your life easier. Maybe. jQuery is one of those things that I just really resist learning. I don't know why. Like I see it, I see the syntax. I just think it's illegible. I think it's really hard to read. A lot harder than just raw JavaScript. And obviously that's just me. That's just my personal preference. But I think they use a lot of weird symbols and stuff, especially $signs all over my code. I just don't like strange symbols everywhere. I like it if my code can read like English. Yeah, and I know that's uncommon. A lot of people love and swear by jQuery. So don't let me stop you. Don't let me change your opinion. Keep doing your thing. But for some reason, I don't know. I don't know. Maybe that's just me. So that's great. We added content after the page loaded, but we didn't get anywhere. We didn't make any progress from HTML and CSS. We could have done that with HTML and CSS, what we just did. No big deal. Yes, we get more interactivity because the page content is loading after the page itself, but big deal. That alone doesn't get us much interactivity. So let's actually get some interactivity and get the roots of how users will actually interact, with our sites, at least one way that they can. And for this, we're going to use JavaScript Events. So JavaScript has a variety of events. You can read all of them here. I shouldn't say all, but you can read about events here. And there are a lot of different events that occur that are triggered by the user that we can hook into and have code that executes on those events. So to do that, we're going to use two different events for here. We have a div on our site, and we're going to react to whenever the user's mouse enters this element and whenever the user's mouse leaves this element. And there are other events on click, on keyboard presses. You can react to anything that the user is doing. You can find a way to interact with that. I'm going to interact with the mouse movements. So when the mouse moves into this, turns blue, out of it, turns green. On the events, on these event listeners, we can call any JavaScript code inside here. And to keep things organized, it's good practice to just call a method, or a function in this case, call a function, And then in your separate JavaScript file, write your functions that actually do have the functionality that you want. So here I'm going to call make blue. I'm going to pass this, which is a reference to the element that I'm currently in, with a reference to this div. And in my JavaScript file, I have a make blue function that takes an element and then sets its color, what else, to blue. And then make green, same thing, same idea. Pass a reference of the element to the function, and then set its color to green. And not full blue, not full green, just like halfway green, having a little bit faded colors for this example. So this way we can start interacting with user actions, which is ultimately what we want. One of the big ones that we'll hook into, or most pages hook into, is a buttons on click event. Of course, go figure. Or submitting a form, which is just another way of reacting to a button press. But there are tons of other events. You can interact to everything that the user's doing, especially if you want to make a browser game. If you're building it from scratch and not using a game framework, it's nice to hook into all kinds of different events to be able to interact with the user. On mouse move is a nice one. If you can follow their mouse and have that moving around a character, on click, they click on the game map somewhere. Maybe they want the character to move to that location. All right, and I added one slide, but I want it here. I want it right now. I'll still say what the other slide is. So we can go into the browser console and run any JavaScript that we want on pages that are not ours. So we don't have to control the site to be able to run JavaScript on them. You open up the browser console, and you can execute any JavaScript that you want on that page. Your own JavaScript, run it on the page. So you can mess around with pages like that. To take that to the next level, you can write browser extensions, which takes your JavaScript and automates that process of opening the console and typing in your JavaScript and running it. A browser extension is going to take your JavaScript and run it automatically after that page loads. So the browser extension, JavaScript code of your own, is effectively injected into that site and runs after the page loads. Now, you don't have full access to everything. Browser extensions are limited with the same restrictions as JavaScript, of course, but also it cannot mess with some of the functionality of that page. So your browser extension and the pages code is going to run in two different environments. So you can't access the variables of that page or the functions. You can't change the functions. You can't read the variables. So there's certain things that you can't do. But you can mess with the HTML. You can modify the DOM in any way you want. And of course, browser extensions, one of the most common or infamous, whatever you want to call it, browser extension type is an ad blocker. What an ad blocker does is once the page loads, it's a blob of JavaScript code that runs, looks for ads, and removes them. Or it can look for the requests and block those requests to the ad servers. But that's what it's doing. It's modifying the HTML, looking for ads, and squashing them. Oh, I don't have my demo slide either. So with that, let's see some examples of this in the next 20 minutes at least. Oh my goodness, where am I? Here we go. I didn't even think about it before, but I don't think I have the example. Yeah, I don't think I do. I don't think I have that example handy that we just saw on the slide. So you can type that one up. You can check that out. I promise when you move the mouse in and out of that div, it does change the colors. So I'll show this one. This page is going to have two buttons. One you can click that calls a function upvote. One that you can click for a function downvote. And a div with the ID of votes that has the value 0 and shows the number of upvotes and downvotes. I import my script voting.js, which has these two functions, upvote and downvote, that we call from those buttons. It's going to increment this variable votes or decrement, and then call this function update display, which is going to get that element and change its inner HTML to the current number of votes. So let's see this page in action. I have it. I promise I have it right here. And you can see, well, I click downvote, it downvotes, and every second, I should have changed this before. And every second, we're actually getting a free upvote here. So any page that we're at, we can go open up the browser console, which it's going to be very very good for your lives if you get really used to the browser console early and use it often. For debugging purposes, it's pretty much invaluable when you're building your websites. Get into this console. You see me go into the network tab a few times. I'm going to go into the console tab this time, and we can see the network tab actually. Our index.html. We can see that HTML. So if you want to look at other sites too, you can see all of their code for their site. We can go to sources and see that content that was downloaded to run the page. And but console is what I want to focus on today. When we're in here, question mark, do you have a question, Zenji Chen? I can answer questions, but I don't know what question mark means. Class started earlier? Oh, if you're in 116, this is CC 312. Shit, I didn't update the title. Yeah, I didn't update the title. Yeah, not 116. So I can open up the browser console and run any JavaScript that I want on this page. So if I want to say upvote, yeah, I didn't think it was. It's capital V. Oh my goodness. I'm not supposed to get stuck on this thing. It is a lowercase v. It's a bad naming convention I have. And downvote. Let's do downvote because it'll be more clear. And I can, let me move this so my face isn't in the way. And I can do something like for yeah, I want that one. Maybe this is something I don't like and I want to downvote it a whole bunch of times. So I can write any JavaScript that I want and run it on this page. I don't have to use the upvote and downvote buttons. So that's great, but for certain things that you want to do, this might get pretty tedious. Yeah, I can call the function. So in the console, this is an important difference between the console and your browser extensions. The console, I can call the downvote and upvote functions. I do have access to all the source. I have access to the variables. I can just set votes to 1,000,000. You know, I can do whatever I want within this environment. This is running in the same environment as the page source. That's not going to be true for browser extensions. So let's talk about browser extensions. So let me go back to VS Code. And I have this browser extension. You can see it running on that page. That's not a bug. That's not something I messed up. I have the upvote function being called every second. I'll get to this in a second. But to write a browser extension, this is very nicely standardized across browsers these days. The Chrome extension protocol, I guess we can call it at this point, has been adopted by every other major browser. So you can write browser extensions in the format of Chrome extensions. So if you Google Chrome extensions, it's going to give you all kinds of good information that's useful for all browsers. But this browser extension format is going to be applicable to all the major browsers. So to write a browser extension, you need two things at a minimum. A manifest.json file. This is going to give all the meta information about your extension. The manifest version number, which is saying which version of the manifest itself, using 2 here. The name of your extension, the version number that you choose for your extension, and the content scripts, which is going to specify which code runs when. So here, with matches, whenever the URL matches this pattern that you give it, this regular expression, then this script is going to run. So whenever I open something with the file protocol, since I'm just using localhost, I don't have this hosted anywhere. I'm just going to say whenever I open something with the file protocol, run autovote.js. Then in the same directory, any JavaScript that you call needs to be in that directory. So I want to run this JavaScript whenever I open a document with the file protocol. And this is going to be specific to, I can say file voting index. Well, that doesn't really work. Maybe that's why I did the index.html. But I'm going to run this script every time that page loads. So for this, I'm going to set an interval, which means call this function every this many milliseconds. So every second, call the upvote function. The upvote function is different. Remember, this is a different environment than the code that the page is running, the page code itself. So this is a different upvote function. I don't have access to the page's upvote function. I cannot call that function. So I can't just say call upvote. I have to create my own function, which is going to mess with the HTML, and then use the HTML to cast my upvotes. So what I'm going to do is look for buttons. If that button has a label upvote, then I'm going to call click on the button. So button HTML button elements have a click function, and I'm going to call click to simulate programmatically a click on that button. And I'm going to click that every 1 second. So we saw that working with 1 second. Oh yeah, I did tell 116 that they should show up to this lecture because it's fun. After lecture, a few students were asking about that. How do I hack websites and stuff? Well, this is a start. This lecture. Not that you should don't violate any terms of services or any laws. I have to add that disclaimer. So let's change this to 10 milliseconds and click the upvote button every 10 milliseconds. Now I'm going to go into my browser. I already have this extension installed. In the next 10 minutes, I'll write one from scratch and show you how to do the whole process. But I already have this extension installed, and I don't know why, but I can never find the extensions. I always go into this and do manage extensions. I already have this one uploaded. I'm going to click refresh. And I did load unpacked. This is going to read from my file system. This is made for developers. Read from my file system and reload that file that I just edited. I can go back to my page, reload it, and now I'm getting an upvote every 100th of a second. So I should get 100 upvotes every second, which looks like it's right on time for that. So let's build a web extension from scratch, and let's use it on an actual website. And I chose CSE312.com. So what I like to do if I'm writing a browser extension is I'll go into the console. Why am I getting warnings on this? I may have to. Browser.js isn't even mine. For the page. Anyway, so go into the browser console and start testing out the HTML that you want to write. So for this browser extension, what I want to do is something that students have asked for a while that I still haven't implemented, and I might not for a while, is dark mode on the course websites. So I'll do a really rudimentary dark mode. And I was practicing this, so I know exactly how I'm going to do this. I'm just going to change the background to black and the text to white on this entire page. So there are a few things that that we want to do. Some stuff that we haven't seen yet is I want to access all of the elements, get elements, and I'm going to get all of the elements by tag name. So I could do like P to modify every paragraph. I could do div to modify every div. Well, I want to modify everything at all, everything completely. So I'm going to do dot star. That's the wildcard. I just want to edit everything. I want to change this to an array. I'm going to cheat a little bit. My mind's blanking. From. Array.from is going to take that data structure and turn it into an array so I can use some array things. What I want to use is for each. Capital E. For each. And then call a function, which actually, let me do it this way. I'm going to define that function first. A dark mode function that takes an element, and then for each element I want to call this function, and I want to do element.style to edit the CSS. I'm cheating way too much on this one. Set property background black. Color white. So I have my function. And I want to call this function on every element. So in my for each loop, I'm going to call that function dark mode, or pass it a function, and then that is going to call this function on every element. And as long as I didn't make any silly typos here, we should see dark mode. So we have black background on everything and white text. It's not the prettiest dark mode. It's very just hack and slashy, but we do have dark mode on this page. So if we refresh the page, we don't have dark mode anymore. So what I want to do is get this code into, actually I can't cut and paste yet, into a browser extension. So let's write a new browser extension. New folder, dark mode. Didn't want it in there. Whatever. That's, no, I can't do that. Do I have to, oh man, just give me a directory where I want it. There we go. Dark mode. I'm going to grab one of these manifest.json so I don't have to remember the format. Change the name. CC dark mode. And I want to change this matches. Matches https cc312.com// So any page on this site. And while we're at it, oh, that's an IntelliJ shortcut. And while we're at it, let's do 116 as well. Now I want to run some JavaScript. I'm going to call my file darkmode.js. New file, darkmode.js. Now I want to go to the browser where I tested the code that I want. And I want to run these 2 lines of code when the page loads. This line, darm mode. Well, it's just going to be darm mode then. And this line. Do I have the full one? There it is. that when I do have to, so I do have to change that because I have it dark mode here. It's not going to see the right file. Just for fun. Well, let's change this to dark mode, but those do have to match. So that actually would have broke things. So I have my code here. Since I don't have to have this all on one line, which you don't in the console either, but I forget the syntax to do multi-lines. Let's expand this a little bit. So I have my dark mode, takes an element and just sets the background to black and the color to white. So we lose all the other coloring of the site. And then grab every single element and call that function on it. So here's our extension. It's all written. Everything's great. So how do we get that uploaded? Because here we don't have dark mode. We only ran that code once. So let's go into our extensions. And this is way easier than you might think it'll be. Let me explain what I'm doing. I find the extensions page. So find the extensions page in your browser and find this, it's called load unpacked here, or load directory, or whatever it is. Load unpacked. And I'm going to find the directory where I stored that, which I think is in idea projects. Dark mode. And I'm going to select an entire directory. Now my browser is going to look at that directory, look for manifest.json. It found it. I can tell because it has my CSE dark mode, the name that I gave it, and the version. This is version 0.0 of CSE dark mode. So I know it read my manifest. It says the sites that it's going to run on. I can disable them if I want, for what it's worth. And have some extra settings for that. Now when I go to 312.com, oh my God, no, just give it to me. All right, and then we debug. Just do it for me. cc312.com darm mode.js. I don't think it would need that semicolon, but we'll try. Do I have to enable it? Oh, were those sliders on disable? Automatically allow access. Yeah, were those on disable? They might have been. Then we have dark mode. And now every time I go to cc312.com, I go to cc116.com, I'm going to have dark mode enabled on these. And then you can modify it, make it look prettier than this. But just a very basic dark mode, done. We have dark mode on this site. And there are extensions, there are third-party extensions that will do dark mode on every page, and that's effectively what they're doing here. They're going through all the elements. I would imagine those extensions are reading the current colors and then changing those colors to a dark mode equivalent. So they probably have some function that converts any color to their dark mode color, and then just changes all the colors on the websites.